Hi and welcome. So, in the retail economy of today's date, and especially so in the developing countries, everybody's fighting for getting some elbow space and making sure that their prices are competitive. So let's look at just one example. Let's look at this website Shop Clues, and let's look at their offering of mobiles and tablets, mobile phones or computers, and then let's look at some other. Let's look at say Amazon, and you'll see that if you really start tracking these websites, there is not much of a difference over there. So and how do you really find out? So let's say I wanted something that's listed here as Zen Ultra Phone Power Max, and now if I went over here and I said okay, Zen Ultra Power Max, does it really come up? Ultra Phone Power Max. I don't even know what these things are, but anyways, it says some Acme something. I don't necessarily get this. Anyways, so did not match any products, it says. So maybe not the Power Max, but the Zen Ultra phone is available, or maybe not. So there's some rich leather something which is there. So these are phone cases. So there's a lot of things which are available, and we are spoiled for choice, and we don't necessarily know how to compare something in one particular portal to the other. So let's say you wanted to do some web scraping, and you wanted to do some web scraping, pull out some information from the internet and compare. Let's say you wanted to compare apples to apples and oranges to oranges in place of running all over these websites, and you wanted all of this done in one particular application. So here is a proof of concept kind of a thing I've gone ahead and developed, and I'm using R. And okay, so here it is. Straight away getting into the code. So I'm using a library called RSelenium, and this was suggested by a friend. What I was using earlier was RWest, so this project is still called RWest, though I'm not using RWest now. And yes, RSelenium is definitely much better. So go on ahead and imported the library and uploaded it. So what we basically need to do is we need to start a server. So this is because this particular library has got functions which will go ahead and input data or pull in data or scrape or harvest data from the internet. So there has to be an internet server which is there. So it says, so I've just written use the default initialization. So I'm saying okay, start server. Okay, sorry, I have not gone ahead and loaded this. So library is in, it calls rcurl, bitops, rjson, xml, and then we say okay fine, start the server. The server started, and what we want to do is we want to have a remote driver which will pull in all of this information. So when we say remote driver, it's basically again I'm not that technically qualified to know exactly what it is, but it's an application or it's a program which is housed within your web browser, which will pull in information, specified information it will pull in, and it will initiate some kind of dialogue between a certain web page and your this server which is there. Okay, so remote driver, and remote driver open in the silent mode, which basically by default means Firefox, and these are all RSelenium functions. So by default is Firefox, otherwise Phantom.js, which is again which is a browser which does not necessarily show you any kind of a presence on the screen. So if you use that particular browser, you won't be able to see anything. So like I can see Chrome over here. If I were to go, I see Chrome existing and things. This is all Chrome as far as I am concerned. So this is Chrome, this is Chrome, this is all Chrome. But if I were to go to Phantom.js, I would not see any of this, but it would still function as a browser. So you could either have Phantom.js, or you could have Safari for Apple, or you could have Google Chrome. But it seems that it works best for Firefox. and with the default options. So I've just gone ahead and I'm using Firefox. So here it is, and my R shows that there is something happening. Shouldn't take much of a while, and we'll see Firefox coming up over here. Yeah, any second now. Until then, let's go ahead and launch XML also. Yes, there it is, Firefox. And now I want Firefox to navigate to a particular URL. So I wanted to go to this particular URL. What is this error? What error is it showing? Okay, we'll leave that error. There is nothing. So anyways, so I wanted to navigate to this particular URL, which is Shopclues Mobile. So we just saw that right now. So let's say I go ahead and enter that. So the moment I've entered that line of code, again it's showing me that something is happening. So I need to wait for a while. But if I go to Firefox, I'll see it's already gone onto that particular website. Now I need not necessarily close this pop-up which is there. But if I don't, then we won't be able to see as to what's on the website. So I close this and I see that we've landed up on the same page which was open in my Chrome earlier. So this is the same page wherein I copied this URL and I pasted it in R, has been opened up remotely. So RSelenium is also used for something called web browser automation. So there are certain functions that I have which I have removed over here. I've removed those, but probably I'll post them somewhere. And they're very common functions. So you can go ahead and enter text. You can go ahead and search text in Google, and all kinds of things you can do. There's absolute automation which is possible. You can navigate ahead. You can come back to the page that you were on earlier, and things to that effect. All of that can be done with RSelenium. Okay, now what we basically want from this page are CSS selectors. And when I say CSS selectors, so that is the style sheets, and then there are certain again, let's say tabs or say indicators of what kind of information lies within them. So those are CSS selectors in the simplest terms. In place of CSS selectors, we could also go ahead and select certain XML components. You could use this other library which is there, and let me see if I have got that here. No, with RWest also I've gone ahead and chosen CSS selectors only. So there is with the library XML, you can choose XML paths also, or X paths also, and that is slightly different and probably not that effective is what I have heard. So I'm just going ahead with CSS selectors. The only challenge being with CSS selectors is that you can't necessarily just go ahead and find them on the web page source. So let me just go to Chrome, and this is how I went into the source of this particular page. And what I'm looking for or searching for on this particular page is old. So old is one of the CSS selectors that I've gone ahead and used later here is .old price. I don't get that over here. So on the web page, I don't necessarily get to see, but I'll come to that. So CSS selectors cannot be searched, by looking at the source code of a web page. That is not necessarily possible. So for CSS selectors search, you need add-in. So there's a Google Chrome add-in, and I'm sure it works in Firefox also, but I've not tried that yet. So it's called a selector gadget, and this is a selector gadget which is recommended by Hadley Wickham and others. So this seems to be pretty much authentic to be used in R. And also I read a couple of other articles on Selenium and web scraping, and I think it's a standard usage CSS selector. So what we basically do is we go ahead and click here. The moment you click on this, it gets activated, and you can see I'm just browsing. I'm not clicking anywhere, and it surrounds this particular CSS element which is this picture, and it says a.img. So I'm not necessarily bothering about these pics right now. So what I'll do is I'll go ahead and click on the names. The names is what I'm looking at first. So I want to see the product names. I want to see what is the price of the product and whether the price has changed over a period of time. And I can't necessarily find out as to what that period of time might be. But what I can surely do is from this I can understand that yes, at one point in time, this was 7,699 is what they've gone ahead and displayed, and now it's 4,799. So which means it has come down by a certain percentage. I might be interested in calculating that percentage, even though they mentioned it over here as 38% or whatever. But I want all of this in an Excel sheet, so I can play around with this data and make these calculations on my own, and then probably choose as to or try and understand maybe over a certain product line or over certain products which particular online retailer is giving me a better deal. So absolutely anything can be done once all of this information is with us. So let's see how to get this information. You go ahead and click on this. Now I'm clicking on the particular page, and down here you get to see dot name and clear 46 toggle position XPath, and this is basically a small widget that has come up, which was not there earlier. So what I do is what is recommended is I keep on clicking on this particular CSS selector, which I presume to be similar to the others, and when I get this dot name a couple of times, that is when I understand that yes, okay, this is actually dot name, the CSS selector, and then I can code it into R. So this is what I've done for my very first web elements. So web elements is what I'm extracting. I've gone ahead and said CSS selector and dot name. Now these could also be called as text headers. So in some, I think in the package examples itself, it is called text headers. I took it up from there. So what I want to do is I want to insert this value into this web element, and then unlist using lapply and get that element text. So that element might not necessarily be in a text format, but I ultimately want text, and then I want that particular text header or as many text headers that I get. So this will be searching the entire web page. So I don't necessarily know how many I will get. One I could do is I could just go ahead and dump it on my console and see as to how many text headers are there, but it's not recommended because it could be a large output also. So, but because I've already tried this out earlier, so I'll go ahead and do this so that you get a feel of what it is. And this is what it is. So the raw dump shows me that there is Zen Ultraphone Power Max, and then there is something else which is mentioned there which I can't read, quad core 1.GB or whatever, and Nosama Virat, the phone with inbuilt power bank and all this. So this is the raw dump which has come out. Doesn't make much sense. So I go ahead and create a data frame. I see the head and tail of that data frame, and this is what it shows me. It's got 46 records, wherein it's got a Zel Ultraphone Power Max, and all of this is here. Okay, fine. So basically I got down the names of all the items that I see here, but it's not from Chrome, it's actually from Firefox, but then that doesn't make a difference. It's the same page that we passed on to it. Okay, so you go in here, and my second web element that I want is dot product price. Now over here there is something that needs to be noted. It's probably just it's something with this particular page. You might not find that in other pages, but if you click on this, it will give you dot product price and the name, because you've already got the name earlier, so it's kind of toggling it with that. But this is the CSS selector, and it's gone ahead and chosen all of these, which shows that all of these, which is this and this highlighted portion now, these are all dot product price. And let's try and validate if that is true. So I go ahead and code it in this manner. I again go through the same steps, and I want now data frame 1. I've coded it. I want to see the head and tail. Luckily I've again got 46 records or observations, and what I have over here, if I look at the first one, it is going right from 4,799 to 579, 5,799 and 7,699, and you can see /n, which means it's gone to the next line. So it's basically a HTML or a CSS this thing. So this is what I've highlighted now is what we've downloaded: 4,799 and 5,799 and 7,699. So these are the figures. You can see them in the console right now. So fine, that is okay, but I can't do much with this. So what we'll do is we'll try and look for some other elements within that, and we will try and choose some other selectors. So if we click on one of these, let's say yeah. So now there is something called old price which is coming up. Now you can see down here dot old price, and that name continues because I think that is, and again I'm getting old price here also. So wherever there is a listing down below, they split it up, and this is all old price. So this could be different for different pages. So just because you got an old price over here doesn't mean you get the old price somewhere else. And this prompted me to go ahead and search within the source code. The raw source code, you don't necessarily have .old -price anywhere. So that does not necessarily mean that you'll get the CSS selector within the raw code of the web page. That will not happen. Okay, coming back to R. So again, just gone ahead and got this into a data frame. It's giving me some error. It was giving me this error earlier also, but that did not necessarily impact what we were doing. So I'll just ignore this for now. And again, one more, and this is .price. Now this .price is what I was ultimately looking for. And over here you'll see this 4,799 is just this one particular here. Now you can see it very clearly. It says .price, old price, and name. So name is something that I've already kind of figured out earlier. Old price also, and price. So these are the 4 components that I'll get out of this as of now, and then we'll continue our analysis, and we can go ahead and search for others also. But as highlighted, these seem to be the most relevant ones that we want as of now. Okay, so perfect. So now I've got all of these data frames over here. 1, 2, 3, 4, and 4 is basically. Now what I could do is I could go ahead and create C-bind these 2 data frames and create one out of these, but that does not work. Why? Because the length of the variables is not same. So in one place I've got 47 and rest of them I've got 46, and this 47 is actually it shouldn't be 47, it should be 46, but there seems to be some challenge over here. As you can see, it's skipped the first one. I don't know why, and that comes out in the data frame also. But anyway, so what we'll do is we'll go ahead and get our working directory and we'll write table. So write table is basically a command wherein we'll go ahead and write the CSVs. So df, df1, df2, df.3 CSVs. We'll get these 4 CSVs onto our local hard disk, and then combine them and do something with it. So fine, okay, let me now show you as to, yeah, you can get these href elements also, basically the web URLs which are linked to the vendors and things to that effect. And this is where the initial web scraping code ends. And just to, okay, this one's still coming now. Perfect. So you see there is some JavaScript voids also over here. It says JavaScript void, So it's given us almost 570 observations, but not or 560 observations, but not all of them are relevant to us. So you can see shop clues over here. Fine. So there is some analytics, Twitter, yeah, targeting mantra, Zetata. So there are various any which way. So this we could look at later on if we want. Now just let me see if I knit HTML and if I want to publish this particular markdown on the web, does that happen? Because it was not happening earlier. So if I can publish it, then I can leave a link with you so you can straight away look at this code. There's some challenges earlier. Challenges being it tries to reopen Firefox. That is another thing that we need to note. It tries to reopen Firefox and it is giving an exception in thread main Java, something bind exception. Selenium is already running on the port. Yeah, so when the server is already launched, so what I should have actually ideally done is I should have gone ahead and stopped the server. I have not done that. That's why it's throwing all this, throwing all these errors. So while we get into anything to do with the web and there are all these servers and things that we are using, we need to get to we need to get used to this. So if you have a technical background, I'm sure you can understand this better than I can. But some of these things will just throw you off for a while, and it will get back to normal then. Okay, so I'm presuming any second it will finish off what it's doing. I think I'll have to wait. The markdown doesn't seem to work, but let me try again. What we have to consider is all of whatever we've written in the script, all of that data is being transferred in again, even though we are not necessarily writing down those data frames onto our hard disk, which again is possible. So I presume this entire thing is getting run once again. So that might take some time. But if that doesn't happen, most of what is here will not come in the markdown. And if it does not, it becomes slightly difficult to share the code. Yeah, I think it's finally there. Okay, so I published it earlier, but I want to again republish, and much better visibility here than on the console and on the video. So republish, update existing, okay, absolutely okay. Now while this is what we've done, I would want to show you as to what can we do further with this information. So you go ahead and scrape similar information from say Amazon, and there is a different script that I have which again I've already shared on the RPubs and on my GitHub. Okay, now what I've done is I've taken all of these data frames offline and I've created this one CSV file. Just a 2 KB file. I've done that manually, and what I want to do now with this is I want to end up automating the analysis. Now over here there have been slight challenges. I have gone through a couple of iterations on Shiny, what I've come closest to and what seems to be doable, let me share that with you now. So ultimately we want competitive data. So presume what is there was a problem sending the command to the pro. That's okay. Let's try that again. Let me close some of these. Okay. Yeah. So on the server side, basic code over here. So you've gone ahead and put in some radio buttons for selection and things to that effect. And there are different, so in place of tabs, I've gone in for pills. It looks slightly much better for Amazon, Flipkart and Shop Clues. These are three that I want to go ahead and get information for. On the server side, what I've done is, it's a little messy. So again, it doesn't work very well. But let me show you as to what can be done. Okay. So it gives us an option to choose the product category as to what product category you want. And it's all kind of grayed out and doesn't look very well right now because there are challenges with the script. So it's not working very well. So let me fix it and I'll probably be able to then share it again. But just as a POC, so mobile computers, appliances or networking, whatever. So you go ahead and choose the file. So let's go and choose the file that we've created over here and Shiny one. And what basically happens is this file gets replicated here, and we end up getting some graphs, but that doesn't seem to be happening. So let me try again and get back to this. Well, it takes a bit to get things sorted out here, but I think now we are okay. And I got a couple of errors, and I had to run it a couple of times, but that's okay. Shiny sometimes still it doesn't get set up properly. Okay, now what's basically happening is this is running on our local server right now. I'll try and launch it on the internet also and share a link with you. I'll do that right away. So it's basically very simple. This thing web app. It says web analytics, Amazon, Flipkart, and Shop Clues. So just choosing different organizations, we can see a versus kind of this thing over here. So if you have the Flipkart data, this is against the Flipkart this is against the Shop Clues one, this Shop Clues 2, and this is against Amazon 1. Most of this is unfortunately right now dummy data that I had to create because what we web scraped was not good enough. So that we've already seen, and you can go and see that this is not something which will give us a lot of information. So I need to probably get back to the web scraping again, but how to automate it, the logic remains the same. And this is my number of observations. I can go to 1,000 observations. I can come down to less number of observations. Let's say we are looking at a standard, say 100 observations, right? And I can move this not only with my mouse. I leave my mouse here. I can move it with the arrow keys on my screen. Sorry, on my keyboard. And let's look at standard 100 observations, and let's look at for different organizations with different other organizations. So this is Amazon with Flipkart, Amazon with Shop Clues. So you're trying to compare. So the data and the frequency as to could be the number of sales in that particular duration or whichever way. So this needs to be worked out, and this is quite flexible. So it's not that difficult to achieve. This is the code. It's very simple code. It has just about 60 lines, 50-60 lines of code. And okay, now let me try and launch this. So the library, Shiny apps, that is one that is required, and deploy app. I think that's about it. Yeah, it says preparing to deploy application. It gives me a challenge sometimes with my login ID because I got 2-3 of them. But let's see, I think this will work. Yes, it's deploying the application. So this application is going to be live on the internet. So what anybody who's watching this video or wherever I share this link, they can go ahead and play around with it and see. So this is just a basic POC. So once the data has been downloaded in a proper manner and we've gone ahead and formatted it in a proper manner, whether it's done online or it's done offline, then it makes more sense to go ahead and play around with it in Shiny. So here it is. This is on the internet, accessible on the internet. And let me go to Google and come back to this. Let's say I go here and I say, okay, fine, Shiny apps. No, let me just put it up here. There you have it. It's live on the net, and you can access. You can have a look as to what is happening and how it is changing. So this is the amount of interactivity and that we can achieve, and these are basic plots. So I have not even gone to ggplot yet, so we can create different plots with that. And what I'll do is I'll put it up on my GitHub. I already have few repositories there. This will be the first Shiny one, and I've been kind of busy in last 2-3 days. I've gone ahead and populated most of these things. So let me go ahead and commit few more, and thanks a lot for watching.